So today's conversation we're talking about is parabolas. You will be able to graph a parabola, write equations for parabolas, as well as find different features of a parabola. All right, this too is another conic like circles was, which is what we talked about in 9-1. But it's a little bit more than what you know of like a quadratic to be, because parabolas don't just open up and down, they can also open left and right. They have some specific features to them, as you can see in this picture, such as a focus, a directrix. It also has different points on the graph that are equidistant from a fixed point. And so a parabola, definition-wise, I'm not talking about a quadratic, I'm talking about just a parabola in general, is a locus of points, so basically a set of points such that each point is equidistant to a fixed point called the focus and a line called the directrix. And so because a parabola is a locus of points, D1, which you see in this general picture, is going to be equal to D2 for all points on the parabola. So that means that any point that's on the parabola, its distance from the focus is the exact same distance from the directrix. Okay, it's the exact same distance from the directrix. Terminology-wise, some different features of the parabola. As you can see here, like I said, they can either open up or down. That's known as a vertical parabola, or it can open left or right. That's known as a horizontal, okay? The focus of a parabola always lies on the inside of the parabola. So this point that lies on the inside, in other words, wherever it opens, that is your focus, okay? So this point here, that is your focus, whether it opens up or down or left or right. The directrix. The directrix always lies on the outside of the parabola. It is represented with a dotted line, horizontal. If we have a vertical parabola, or it's vertical if we have a horizontal parabola, meaning it opens left to right. Now the directrix and the axis of symmetry, that word should be familiar from when we went over quadratics back in semester 1, are always perpendicular. Who remembers what the axis of symmetry is? Is that middle of the parabola. It's like that imaginary line that cuts through the vertex of your parabola, okay? So the directrix and the axis of symmetry are always perpendicular. And the axis of symmetry was always the, well, when it opened up and down, it will always be the x coordinate of the vertex. When it opens left to right, it's going to be the y coordinate of the vertex. Now the vertex itself, that point right there, is always absolute value of P units away from the focus and the directrix. So there's a value that's indicative of P that is essentially the distance from the vertex to the focus and the vertex to the directrix, okay? So again, from the vertex to the focus is P, and that same distance is how far the directrix is from the vertex. Trying to color code it so you can see all the different pieces. All right, lots of terminology here. Now the latus rectum is a segment that passes through the focus, okay? It passes through the focus and its endpoints are on the parabolic curve, and it has a length of 4p, right? So it is a segment that essentially helps us draw the parabola. It goes through the focus, and its endpoints are on the actual parabola. So essentially, see how straight of a horizontal line I can draw here. This will be the lattice rectum. It goes through the focus, and its endpoints are actually on the parabola. That is actually what's going to help us draw our parabola, whether it opens up or down, left or right, and essentially how wide it is going to be. Now, standard form for a parabola, okay? This is kind of like following along with the notes. So this is for those that are vertical. These are for the ones that are horizontal, okay? Vertical is essentially what you know. Those are like the classic quadratics that you guys have been working with before. This is when your x's are being squared. So standard form is x minus h squared equals 4p y minus k. That is the standard form for a vertical parabola. You'll know if the parabola opens up if the value of p is greater than 0, and it'll open down if the value of p is less than 0. Or in other words, if this part right here is positive or negative. What do you think h and k represent? A specific point, an important point. It represents the vertex, okay? It represents the vertex. So the same h and k that represent the center in a circle, the central point, is the vertex in a parabola. When it opens left or right, it's going to be y minus k squared equals 4p x minus h. And you guys have that reference sheet that was at the beginning of the packet that has those standard forms in there, okay? It'll open to the right if p is greater than 0. It will open to the left if p is less than 0. Notice the differences. X's are squared when it's vertical, Y's are squared when it's horizontal. Still, HK is the vertex. You just want to be careful to not mix them up, because since it's Y minus K, K is still the Y coordinate of the vertex. So when you see it, you might be tempted to put K first, then H. Don't do that. It's still HK. So now that we have pretty much all of our definitions of the different pieces or different features of a parabola, and we have our standard form, let's talk about graphing parabolas. This part right up here at the top is very helpful, okay? When you graph a parabola, you always want to make sure that it's a standard form and determine if it's going to be a vertical or horizontal parabola, okay? That'll kind of give you an idea of which way it's going to open. Of course, graph the vertex, which you'll be able to see when it's in a standard form, that is HK. Solve for P to determine the direction that is opening, but not only that, but also determine where the focus is located as well as the directrix. Because remember, P is the distance from the vertex to the focus and from the vertex to the directrix. So once you figure out P, you'll actually figure out where each of these items are going to be located. Then you'll use the absolute value. So like I said, you use P to graph the focus and the directrix, and you'll use 4P to graph the endpoints of the lattice rectum. Remember, that tells us how wide the parabola is going to be. Once we know that, we can do a quick sketch, because we'll have the vertex and we'll have 2 points that are on the parabola. First off, the equation is already in the standard form, so we don't have to worry about doing any completing the square or anything like that. So we're good. But let's determine, is this going to be a vertical parabola or a horizontal parabola? Vertical. It's going to be vertical. You know it's vertical because the x's are being squared. When the x's are being squared, that means it's going to open either up or down, aka vertical. Let's find the vertex. The vertex is HK. And it still follows like the same way that it was for the circle, still follows here. What do you think the vertex is going to be?
4, -3.
It's going to be 4, -3. Remember, it's always the opposite on the inside there. So I'm going to go ahead and plot that 4, -3. We want to solve for P to determine the direction that is going to open. Since we already know it's vertical, if P is positive, it's going to open up. If P is negative, it's going to open down. So when you think about the general form, which is x minus h squared equals 4p y minus k, 4p is what 2 should equal. So 2 should equal 4p. When I solve for p, I see that p is going to be equal to 1/2. Since P is positive, this is going to open up or down? It's going to open up. Not only is the graph going, the parabola going to open up, but I also know that my focus is going to be on the inside of that parabola that opens up. And the focus is going to be located 1/2 unit away from the vertex. And it's going to be on the inside. Okay, I wish I could blow this up a little bit bigger so y'all can see it. But if I'm at 4, -3 for my vertex, then my focus is going to be 1/2. I probably can't see that online. 1/2 unit from my vertex. What point is that located at? 4, -2.5. My directrix is located that many units away from the vertex on the outside. And it is drawn as a dotted line. And since it opens up, it's going to be a horizontal dotted line. When we do the next one, the p-value will be a little bit bigger, so you'll have the space and you'll be able to see it a lot better. This wasn't a good first starting one, so it's a little hard to see. Okay. But what y value is that? -3.5. And since the directrix is always an equation, it is y equals -3.5. Now we're going to use the absolute value of 4p to sketch the endpoints of the lattice rectum, which means that 4p was equal to 2. That means from the focus, the edges of my parabola should be a total distance of 2 units away from each other, which means I essentially split 2 in half. So that means I should be 1 unit to the left and 1 unit to the right. And that's essentially how wide it's going to start to open. So these endpoints that are 1 unit to the left and 1 unit to the right of my focus are the endpoints of my lattice rectum. So that's at +3, -2.5. And +5, -2.5. So now that I have those endpoints of it, I can connect them to my vertex to draw my parabola. So from my vertex, I should hit that endpoint. And of course, it's going to continue to get bigger and bigger as it increases. For my vertex, hit that endpoint of the lattice rectum and continue to open up that way. There is the graph of my parabola. The dotted pink was to help remind me that it was opening up. My axis of symmetry is the imaginary line that goes through the vertex. So that's going to be x is equal to 4. So straight through the center of my parabola. And that's how we graph a parabola and identify all of its features. Copied over the kind of like the directions to help you out a little bit. Is it already in standard form?
Yes.
Is it horizontal or vertical?
Horizontal.
It is horizontal. You know this because the y's are squared, which means it's going to open either left or right. Now be very careful here. Because it's horizontal, when we do the vertex, remember it's HK. H is with your X, K is with your Y. So my vertex is going to be 5, 1. Remember, standard form, y minus k squared equals 4p x minus h when it's horizontal. So 5, 1. Let's determine the value of p. P is going to help me find my focus, my directrix, and also the direction that it's opening. I'm going to set 4p equal to what number? -16, because in the formula, that -16 is in the 4p spot. So solving for p is going to equal, so since p is negative, does that open left or right? Left. Remember, if p is negative, it's going to open left if it's horizontal. So that lets me know I'm going this direction. Please make sure we know our lefts from our rights. You can always hold up the L's. The left is the one that looks like an L when you look at it, okay? Now the absolute value of P, okay? The absolute value of P, which will be +4, will help us identify where our focus and our directrix is. So +4, that means that P is going to be 4 units on the inside away from the vertex. Since it opens to the left from my vertex, I'm going to go 4 units to the left. And so the focus is located at 1, 1. The directrix is located on the outside of the parabola. That same distance away that the focus was. What was that distance? So I'm going to go 4 units on the outside. And remember, the directrix is not a point, it is a what? It's a line, which means when I write it, I'm going to write it as an equation. When I draw it as a dotted line. Now, since that directrix is horizontal, the equation is going to be, and there's going to be +9. I'm doing okay so far. I hope I'm not saying anything. Let's find those endpoints. The absolute value of 4p, which is 16. So that means from one endpoint to the other endpoint, that should be a total of 16 units. Which means I need to go how far above my focus, how far below my focus? 8 units. So this one's going to be pretty large. Okay, so 8 units above the focus and 8 units below. A point right there. What are those points? Right, they are 1, and 1, and so from my vertex, I need to draw my parabola to go through those points. Okay, so this one's going to be a wide one. Like so. I'm my best. Struggling on these. They ain't pretty. They ain't pretty. Last little bit is my axis of symmetry. Remember, that has to go through my what? Focus and vertex. Since this is horizontal, it is going to be y equals 1. That's my axis of symmetry. So there we go. We've graphed this one. This one's a lot easier to see because things were a little bit more spaced out. This one, is it in standard form? No, it's not, because if you go back and you look at your standard form, it should be y minus k squared equals 4p x minus h. But it looks like my 4p is with my square term, and it shouldn't be. So for this particular one, I am going to need to write in a standard form before I can start doing all my pieces. How do I get rid of that 1/10? How do I bring it to the other side? Multiply it by 10. When I multiply this side by 10, what happens to the 1/10? It cancels out. But when I multiply by 10 over here, I don't want to distribute. I want to leave that 10 on the outside because that 10 is my 4p. So don't distribute it through. You're just going to end up factoring it out later. Okay? Vertical or horizontal? Horizontal. Remember, our y's are squared. So when our y's are squared, it's horizontal. What's my vertex?
3.
Remember, it's HK. Let's find our P. I have to set 4P equal to what number? 10. That's why I needed that 10 over there. So that's what I was setting equal to, not 1/10, but to actually 10. Now, when I divide by 4, that does not go in evenly.
Miss Anderson,
Yes, ma'am.
why did we put the vertex at -3, +2 instead of +3, -2?
Because I'm an idiot. Thank you for that correction. Thank you for that correction. I wrote it right. I plotted it wrong. This whole graph would have been all the way type of backwards. Thank you. Thank you. I'm so glad you called me at the beginning. I can only imagine if I did everything and had it in the wrong spot. So yes, thank you. What is 10 divided by 4? It is 5/2, and I can't believe I'm actually going to say this because y'all, I do not like decimals, but I am going to need to plot my focus. So it's going to be a little bit easier if I have it as a decimal than actually a fraction. So P is going to be a 2.5, technically 5/2, but 2.5. Is it going to open left or right? Right. And again, we identify that as horizontal at the beginning, so then that already eliminates 2 of the options it could open. And then I look at what P is to determine exactly which of the 2 it's going to be. So I am going to open up to the right. I don't know how far just yet, but I always like to put that little guide in, especially since I'm about to plot the focus and the directrix. So I need to go 2.5 units to the left and to the right to get my focus and directrix. My focus is on the inside of the parabola. So is the focus going to be to the left of the vertex or to the right of the vertex? To the right, and it's going to be 2.5 units. What is that point? 5.5. Comma -2. My directrix is that many units, but it's on the outside. So if I go 2.5 units, that's actually going to put me right here. What value is that? Go louder. 0.5, 0.5, x equals or y equals? X. get those points for the lattice. Remember, that's the absolute value of 4p. Well, 4p was equal to 10. So that means from endpoint to endpoint should be a total of 10 units from the focus. So from the focus, how many up, how many down? That should be here. Ooh, I was almost spot on with my little quick sketch. That's going to be 5.5, comma what? And 5.5, comma. And from my vertex through those points, that's how wide it is going to be to get my sketch. What's my axis of symmetry? Y equals negative. All right. So we talked about graphing. We talked about finding its features. Now let's make sure that we can write any parabolas in standard form. And then we're also going to practice identifying which way it opens. Okay. So we have a few examples here. None of them are in standard form, so we have to rewrite them. To rewrite them, we are going to need to use, potentially, we might need to use completing the square. To be honest, we're going to be completing the square literally for every kind. Like I said that for the last unit. So you can't get away from it. You got to know how to complete the square. Okay. First off, you always want to identify your squared term, because remember, that's going to be on the side by itself, right? Our square term for number 6 is y, which means that all the other terms, since they don't have a y in common, there's a constant there, they need to go to the other side. So with this, I'm going to leave the y squared on the left, then I'm going to subtract 12x and subtract 24 over to the other side. So whatever my square term is, and if it has like the singular variable as well, I would have left it over there on the left side, but since there wasn't, only the y squared was on the left, then my x term and my constant term went to the other side. I'm almost there. I don't have to complete the square for the left side because there isn't another term over there. But on the right side, I need my 4p, which means I'm going to need to factor out the GCF, which is going to be what? It is going to be 12. More specifically, it's going to be a negative 12, because your x needs to be positive. It needs to be x plus a number or x minus a number. So when I factor out negative 12, it's going to be x plus 2. And now it is in standard form. Now it's in standard form. So you're going to have to do GCF factoring for the non-squared side to get it into the form it needs to be. And there's a possibility you might need to complete the square on the squared side. Is this vertical or horizontal?
Horizontal.
How do you know?
The
The y's are being squared. So that means it's either going to open left or right. It is going to be left because p is negative. Even though we didn't solve for p, since it's a negative 12, we would technically have said negative 12 equal to 4p and found that p was negative 3, which again indicates that it's going to be left. So get 7. Not in standard form. My square terms need to be on the same one side. Everything else needs to be on the other side. This one's different from 6 because not only is x being squared, but don't I have another term that has an x? So that needs to stay on the same side. But that y term needs to move over with the constant. So that's going to be a what? Positive or negative? Here we are going to need to complete the square because it needs to be in that x minus h squared form. So remember, when you're completing the square, whatever you do to one side, you have to do to the other. You add it. How do I complete the square? I take my b value, which is -10, divided by 2, which is, then I square it, and that becomes, so 25 is the completed square. When we complete the square, we turn the left side into a perfect square trinomial. And it's going to be x minus 5. We know it's at x minus 5 because it's whatever number we get when we take half of b. And on the right, it's becomes 6y minus 6. What do we have to do to the right side? Before, when we had added that 6y over, maybe you recognize that, oh, there's no GCF between 6 and 31. That's because we had to complete the square. Once we complete the square, now there is a GCF, which allows us to put it fully in its standard form. What's the GCF? So that'd be y. Horizontal or vertical? And it opens up. What would the value of p? What would the value of p? What would have been the value of p? Can't talk. 3/2. Because you would have said 4p equals 6. We okay? You want to do 8 together? You want to try 8 on your own?
Yeah.
Give it a try. Give it a try. Hopefully you recognize that my x's were being squared, so you kept your 2x and your x squared on the same side. But when you brought over the 20y and the 61, hopefully you remember you had to subtract 20y and subtract 61. Since they were both positive, when you move them to the other side, it would be a minus. So let's complete the square. What's half of 2 squared? So I add 1 to both sides. If you did get to a point where you notice on the GCF side, you're like, there's no GCF between them, or at least one where I don't end up with just a regular y, that might have meant something was wrong with your constant. How does the left factor? This turns into -20y minus 60. What's the GCF? So I have a y plus 3. Up, down, left, or right? Down, because it is vertical, horizontal. Vertical. Somebody online, what would be the vertex of this parabola?
-1, -3.
Very good. Very good. Do number 9. Is this one vertical or horizontal? How do you know? Your y's are squared, but my y squared doesn't have its y with it, so what do I have to do with that 14y? And then that's -2x. I add it to the other side. I'm taking half of, so it's having -14 squared. So I add that to both sides. Not the same blue, I thought it was another one. So this factors down to b. And over here it becomes 2x. There you can see your GCF is, so I have x, and this opens right. Because remember, I asked you, is it horizontal or vertical? You told me horizontal because the y's were being squared. So that gives you to left or right. Look at your 4p. If your 4p is positive, it's going to open to the right. What is the value of p? Be 1/2. Because I would say 2p equal to 4, and I would solve. Somebody online, what would be the vertex of this parabola?
Negative. Oh, sorry.
That's okay.
7.
I like the feeling. Yes, -2, 7. Yes. Very good. Very good. So this is the first part of parabolas. Yes.
Why is it plus 2 in the parentheses?
Oh, because back up here when we had -45 plus 49, that gave us a positive 4. So then we factored out the 2, which was positive. It kept it as a positive 2. And so just make sure that when you're moving your terms to the others to opposite sides, here we would have added 2x, not subtracted it. And then we would have subtracted 14y to the other side. So to be very careful on those signs. This is the first part of parabolas, graphing it, identifying its features. On Friday, we're going to write the equation given its features or given a graph, okay? So these steps are good to kind of keep in mind. Here's your standard form and recognizing when it opens left or right. And of course, we talked about our definitions from before.